Hello children, welcome back to my channel. Now I am dealing with 9th class maths quadrilaterals. This 8.7 theorem, midpoint of triangle, midpoint theorem of triangle. The line segment joining the midpoints of two sides of a triangle is parallel to third side and also is half of it. So we have got a triangle A, B, C and D and E are the midpoints. The line joining the midpoints of a triangle is parallel to the third side and also half of the third side. So what is given to us? We have got a triangle ABC. D is the midpoint of AB and E is the midpoint of BC. This is D. D is the midpoint of AB. E is the midpoint of BC. This is given to us. What is RTP? What is that we need to prove? DE is parallel to BC. This is first bit. And the second bit is DE is half of BC. So a line joining the midpoints of two sides of a triangle is parallel to third side and also it is half of the third side. This we need to prove. So let us go for construction. What is the construction? Construction is we have to extend DE. This DE should be extended like this and draw CF parallel to BD. Draw CF parallel to BD and F lies on the extension of DE. This is the construction. You have to extend. This is extension. We have extended DE. This DE is extended and CF is drawn parallel to DE. So that what happened? It is intersecting extension of DE at F. Now let us go for the proof. Let us take triangles. In triangle ADE and triangle EFC. ADE and EFC. Angle A is equal to angle C. They are alternate angles. Angle A is equal to angle C, alternate angles. AE is equal to EC. This is given to us. E is the midpoint. So AE is equal to EC. And angle AED is equal to angle CEF. They are vertically opposite angles. These two angles are equal. They are vertically opposite angles. Therefore, triangle ADE is congruent to triangle EFC. So when these two triangles are congruent, what you can say? DE is equal to EF. When two triangles are congruent, DE is equal to EF. Let me write that also. DE is equal to EF. Let it be written like this. Now, what we have got, children? CF, DE is equal to EF, and also we can write CF is equal to AD. CF is equal to AD because these two triangles are congruent, opposite sides are equal. but AD is equal to DB. This is given to us. They said D is the midpoint of AB. It is said. That means what? AD is equal to DB. CF is equal to AD. AD is equal to DB. Therefore, CF is equal to DB. CF is equal to DB. We know that also CF is parallel to DB. This is our construction. We have constructed. Therefore, we can say that, see, opposite sides, this is equal to CF is equal to BD and CF is parallel to DB. That means, let me write the statement, opposite sides are equal and parallel. We have got with this. Therefore, what we can say, BCFD is a parallelogram. Therefore, BCFD is a parallelogram. If BCFD is a parallelogram, definitely DE is parallel to BC. Therefore, DE is parallel to BC. So the first part we have proved DE is parallel to, when you have got BCFD is a parallelogram, DE is parallel to EC. This E should be seen properly. Okay, DE is parallel to PC. Okay, after doing that, now we need to prove that DE is half of BC. Second part we have to prove. DF, now we know that if this is a BCFD is a parallelogram, we can say that BC is equal to DF, opposite sides of parallelogram. That means what is DF? DE plus EF. But this can be written as, say, DE is equal to EF. So instead of EF, I can write DE plus DE. I can write DE plus DE. If that is the case, therefore, BC is equal to 2 times of DE. Therefore, what is DE? DE is BC by 2. BC by 2. So, this means half of DE is equal to half of BC. Hence, proved. So, this is the proof for this theorem, children. Very important. Now, listen once again, children. This theorem. What does the theorem says? In triangle ABC, if a line joining midpoints of two sides of a triangle is parallel to third side and also is half of third side. So, in triangle ABC, D and E are the midpoints of AB and AC, and DE is drawn. DE is joined. Now what you have to prove? RTP DE is parallel to BC and DE is half of BC. For this construction is you have to extend DE to F. On extending DE to F, you have to also draw a line parallel to CF, parallel to BD, and F lies on extension of DE. So draw parallel CF parallel to BD and F lies on the extension of DE. Now let us go for the proof. In these two triangles, triangle ADE and triangle EFC, in these two triangles, angle A is equal to angle C, they are alternate angles because how can you say that? Because we have drawn AB and CF parallel lines. So this becomes a transversal, so alternate angles. AE is equal to EC, they have already given. Angle AED is equal to angle FEC, vertically opposite angles. So two triangles are congruent. If these two triangles are congruent, see DE will be equal to EF and CF is equal to AD. Now, what we do is CF is equal to AD we have got, but AD is equal to DB they have given. That means CF is equal to DB. And we know that CF, we have constructed CF is parallel to BD. And now we are proving that CF is equal to BD. That means opposite sides are parallel and opposite sides are equal. So BCFD is a parallelogram. When it is a parallelogram, DE will be parallel to BC. So this part we have proved. Now we need to prove D is half of BC. See, BC is equal to DF because they are opposite sides of the parallelogram. And what is DF? DE plus EF. But here we said DE is equal to EF. So instead of DE plus EF, I have written DE plus DE. You can see it here. DE plus DE. That means what? BC is equal to 2 times of DE. That means DE is equal to BC by 2. So DE is equal to half of BC. This is the proof, children. Please note it down. Now, the next theorem, children, 8.8. The line drawn through midpoint of one of the sides of a triangle and parallel to another side will bisect the third side. See, children, this is a triangle A, B, C, and D is the midpoint of this triangle. And if you have drawn a line L, this is parallel to another side. So the line drawn through midpoint of one of the sides of a triangle and parallel to another side will bisect the third side. You have to prove that AF is equal to CF. So what is given to us? Triangle ABC. I'll write in triangle ABC, AD is equal to DB, that is given to us, and line L is parallel to BC. Line L is parallel to BC. Line L through D, I'll write. Line L through D is parallel to BC. Now here we need what is RTP. First we have to prove what is RTP. RTP required to prove, we need to prove that AF is equal to FC. This we have to prove. Here we have got a construction. Construction is draw. Let me name this as AE. AE is equal to EF. Okay. Now construction, draw CF parallel to DB. CF parallel to DB. F lies on the line L. Now proof. See, children, they have given here we can say DF is parallel to BC. It is given to us. They have given no that this is parallel to this. This is extra. This line is drawn in such a way that it is parallel to one of the sides. So DF is parallel to BC. They have given to us. CF is parallel to BD. This is our construction. We have constructed. Therefore, BCFD is a parallelogram. BCFD is a parallelogram. So when BCFD is a parallelogram, now what is your task? We need to prove AE is equal to EC. So when BCFD is a parallelogram, its opposite sides are equal. So what you can say, CF is equal to BD. But BD is equal to AD, this is given to us. Therefore, what you can say? CF is equal to AD. CF is equal to AD, we have done. Now go for triangles. In triangle ADE and triangle CEF. In these two triangles, just now we have proved that AD is equal to CF. It is proved just now. We have proved AD is equal to CF. We have proved angle A is equal to angle C, alternate angles. Angle A is equal to angle C, alternate angles, because these two are lines drawn parallel. So alternate angles. Similarly, angle D is equal to angle F. Angle D is equal to angle F. They are also alternate angles. Therefore, triangle ADE is congruent to triangle CEF basing on angle side angle property. Basing on angle side angle property. So when you could prove that triangle ADE is congruent to triangle CEF, you can prove that AE is equal to EC. Therefore, AE is equal to EC, hence proved. This is the proof of this theorem, children. So let me explain you once again. The line drawn through the midpoints of one side of a triangle and parallel to another side will bisect the third side. So this is line L is drawn through midpoint of AB of a triangle ABC, and this is drawn parallel to BC. The question, what is RTP? We need to prove E is the midpoint, that is AE is equal to EC. We have to prove. Now there is a construction, draw CF parallel to DB. Now, when you are drawing CF parallel to DB, see children, they have given DE is, that is line L is parallel means DE is a part of L. So DE is parallel to BC. They have given CF is parallel to BD or DB. We have done our construction. So BC of D is a parallelogram. If it is a parallelogram, opposite sides are equal. So CF is equal to BD. But BD is equal to AD they have given. So CF is equal to AD we can say. Now in these two triangles, AD is equal to CF, we have got angle A is equal to angle C, alternate angles. Angle D is equal to angle F, they are also alternate angles. So two triangles are congruent by angle side angle property. When these two triangles are congruent, AE is equal to EC. This is how you have proved this theorem, children. Please note it down. Example 7, children. Please go through your textbook. I am reading the sum. Example 7. In triangle ABC, DEF are the midpoints of the sides AB, BC, CA respectively. So there is a triangle ABC. This is A, B, C. In this, D, E, F are the midpoints of AB. So D is the midpoint of AB. E is the midpoint of BC, F is the midpoint of EC. D, E, F are the midpoints of AB, BC, CA respectively. Show that the triangle ABC is divided into four congruent triangles when the three midpoints are joined. So if you join the three midpoints, you are getting another triangle. So you have to show that triangle ABC is divided into four congruent triangles when the midpoints are joined. So this is the one. Now, what is given to us? They have given that in triangle ABC, D is the midpoint of AB, E is the midpoint of BC, F is the midpoint of AC. What is RTP? You have to prove that triangle D, let me name them as 1, 2, 3, 4. Triangle 1 is congruent to triangle 2, is congruent to triangle 3, is congruent to triangle 4. We need to prove this. That is, this DEF is dividing the triangle into 4 congruent triangles. So, let us see the proof. So, children, DF are the midpoints of triangle ABC. So DF is parallel to BC. DF is parallel to BC basing on the theorem which we have learnt. A line drawn through midpoints of two sides of a triangle is parallel to third side. That means DF is parallel to BC. Also, DF is half of BC. This is also theorem. We said that the line joining through midpoints of two sides of a triangle is parallel to third side and also it is half of third side. So half of BC. That means what, children? Half of BC. Half of BC is BE. Half of BC is BE. So therefore in BEFD, opposite sides are parallel and equal. See, DF is parallel to BE because when you say DF is parallel to BC, BE is a part of BC. So, DF is parallel to BE. And DF is equal to BE, just now we have proved. So, that means opposite sides are equal and parallel. Therefore, BEFD is a parallelogram. When opposite sides are equal and opposite sides are parallel, it is a parallelogram. Then DE is a diagonal. DE becomes diagonal. So when DE is a diagonal, diagonal bisects. Diagonal bisects the parallelogram. This is also a theorem which you have learned. Diagonal bisects the parallelogram. Therefore, bisects means dividing it into two equal halves. Therefore, triangle 1 is congruent to triangle 2. We could prove that triangle 1 is congruent to triangle 2. So, similarly, we can prove that in the same way we can prove that triangle 1 is congruent to triangle 3, triangle 1 is congruent to triangle 4. When you take about 3, this becomes the parallelogram. So this is a diagonal, these two are equal. When you talk about 4, this is a parallelogram, diagonal, these two are congruent. Same proof will come for all. That is why I have written similarly. So we can say that triangle 1 is congruent to triangle 2, is congruent to triangle 3, is congruent to triangle 4. This is the proof that we have done for this problem, children. Important one it is, children, essay type question. What is that they have said? In triangle ABC, D is the midpoint of AB, E is the midpoint of BC, F is the midpoint of AC. When D, E, F are joined, you have to prove that this triangle ABC is divided into 4 congruent triangles. So, I have named this as 1, 2, 3, 4. Now, when you talk about here, DF is parallel to BC, it is our construction. and DF is it is the theorem which we have learned. When a line is drawn through midpoints of two sides of a triangle, it is parallel to third side. Just now I have taught. And also it is half of third side. So BE is half of BC. So DF is equal to BE. DF is parallel to BE. DF is equal to BE. So BEFD is a parallelogram. If this is a parallelogram, DE becomes the diagonal. Well, we know the property that diagonal bisects the parallelogram. We have even proved in some theorem. So when it is bisecting the parallelogram, we can say that bisecting means what? They are dividing it into two equal triangles. So triangle 1 is congruent to triangle 2. Similarly, we can prove triangle 1 is congruent to triangle 3. Triangle 1 is congruent to triangle 4. So all the four triangles are congruent. So DEF is dividing the triangle into four triangles of congruent nature. Please note it down. The example 8 children. Listen to this children, I am reading. L, M and N are three parallel lines. So let me first draw the parallel lines. L, M and N. So L, M, N are three parallel lines intersected by transversals P and Q. So you have a transversal like this. This is P, and another transversal like this. This is Q. Intersected by transversal P and Q at A, B, C and D, E, F. This is A, B, C, D, E, F. At A, B, C and D, E, F, such that they made equal intercepts A, B and BC. That means this part is called intercept children. These two are equal, they said. They made equal intercepts at AB and AB and BC on transversal P. Show that intercepts DE and EF are also equal. So what is given to us? You have got line L parallel to M parallel to N. P and Q are transversals, and P intersects L at A and M, L at A, M at B, N at C. And they have given AB is equal to BC. Then Q intersects L at D, M at E, N at F. This is given to us. Three parallel lines, L is parallel to M and M is parallel to N. P and Q are two transversals. These transversals are intersecting L element at A, B, C, D, E, F. Q intersects at D, E, F. P intersects at A, B, C. And also they have given AB is equal to BC. We need to prove DE is equal to EF, and there is a construction. What is the construction, children? You have to join A and F. Join AF. Now proof. See, when you are joining AF in triangle ACF, in triangle ACF, M is parallel. Line M through B is parallel to line N through line N is drawn through C. B, what is that? In triangle ACF, line M, this is line M, is parallel to, but the line M through B is parallel to line L through C. This is given to us. This part is given to us. Therefore, let me call this as a G. Therefore, AG is equal to GF basing on the theorem. Just now we have done a theorem. What is that? If a line is drawn through midpoint of one side of a triangle parallel to the second side bisects the third side. So AG is equal to GF. This we can put in triangle AFD or ADF. In triangle ADF, see line M through B, line M through B is parallel to line L through A. Line L through A. This is given to us. Line M through G. G is the midpoint, just now we have proved. Through G is parallel to line L through A. So when it is done like that, what you can say? This line through midpoint of one line in a triangle, through midpoint of one line, if a line is drawn parallel to the other side, it bisects the third side. So we can say that DE is equal to EF basing on the theorem we have learned. This is how we have proved that DE is equal to EF, children. That is RTP. Oh, sorry, I have not written RTP, children. What is RTP? We need to prove DE is equal to EF. This we have to prove. RTP is that. So let us say, children, once again, this theorem 8. In this theorem 8, L, M, N are three parallel lines. P and Q are intercepts which are intersecting L at A, M at B, N at C for P, and L at D, M at E, N at F for Q. And also the intercepts AB is equal to BC. This part is called intercept. These two intercepts are equal, they have said. We need to prove DE is parallel to EF. Required to prove DE is parallel to EF. For this we need a construction, that is join AF. When you are join AF, see children, in triangle ACF, line M is drawn parallel through B is drawn parallel to line L through C. That means what? Through midpoint of one side of a triangle, line is drawn parallel to the other side. Then it bisects the third side, we have proved in the theorem. So directly we can say AG is equal to GF. Now if you take triangle ADF, here this G line M is drawn parallel to B, and also line M through B is drawn parallel to line L through A. So what is happening? A line joining through midpoint of a side of a triangle and parallel to the second side bisects the third side. So DE is equal to EF. You can prove. This is the proof of this theorem, children. Please note it down. Now, the next theorem, children, example 9, listen to it. In the figure, AD, this is AD, and BE. AD and BE are medians of triangle ABC, and EF and BE is parallel to DF. BE is parallel to DF. Now we need to prove that CF, this is CF. F is the midpoint. Also they said that BE is parallel to DF, and prove that CF is equal to 1/4 of ESC we have to prove. See children, median, AD is median means through midpoint of BC, AD is drawn. And E is the midpoint of ESC. So what is given to us? In triangle ABC, AD is the median on BC and BE is the median on AC. Okay, and what else they have given? AD BE is parallel to DF. This is also is given to us. BE is parallel to DF. These two are joined. In the figure, AD and BE are medians of triangle ABC. BE is parallel to DF. Prove that RTP. What is RTP? We need to prove that CF is equal to 1/4 of AC. This is we need to prove. So let us go for the proof, children. Now here, what is that they have given? D is the midpoint of BC and E is the midpoint of AC. And BE is parallel to DF, they have given. When BE is parallel to DF, we can say that F is the midpoint of BE. We can say F is the midpoint of BE. Proof, children. Let us go for triangle BCE. In triangle BCE, D is the midpoint of BC. This is given to us. D is the midpoint. AD is the median means D is the midpoint of BC. And DF is drawn parallel to BE. Therefore, we can say that F is the midpoint of CE. F is the midpoint of CE. Now, when you say F is half of CE, that means what? Therefore, CF is equal to half of EC. F is the midpoint means CF is equal to half of EC. That is half of what is EC? EC is nothing but half of EAC. Why? Because E is the midpoint of AC. So we'll say half of AC, that is 1/4 of AC. Therefore, CF is equal to 1/4 of AC. This is the proof, children. So let us see once again. What is that they have given? In triangle ABC, AD is the median on BC and BE is the median on AC, and F is the midpoint, DF is drawn parallel to BE. Now we need to prove that CF is equal to 1/4 of AC. That we have to prove. Now if you take triangle BCE, in this DF is parallel to BE they have given, and we know D is the midpoint because AD is the median. So through midpoint of one side of a triangle, if a line is drawn parallel to the second side, bisects the third side. So F is the midpoint of CE. So what is CF? CF is half of CE. What is CE? It is half of AC. So 1/4 of AC. CF is equal to 1/4 of AC. Please note it down. Example 10, children. ABC is a triangle and through ABC lines, lines are drawn parallel to BC, CA and AB respectively, intersecting at P, Q and R. ABC is a triangle. Through A, one line is drawn parallel to BC. Through B, one line is drawn parallel to AC. So these parallel lines, these two are parallel, and these two are parallel through B and through C. These are parallel. What are they? PQ is parallel to AB. So like this, parallel lines are drawn. Now the question is, what is RTP here? You have to prove that RTP is perimeter of triangle PQR is equal to 2 times perimeter of triangle ABC. This we need to prove. Now let us go for the proof, children. Proof. See, children, ABCQ, 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 and ACBR and ACBR are parallelograms. Why are they parallelograms, children? Because opposite sides are parallel. Why? Because opposite sides are parallel. Therefore, BC is equal to AQ and also BC is equal to AP. Because for this parallelogram, these two are opposite sides. For this parallelogram, these two are opposite sides. Why are they said opposite sides of parallelogram? Opposite sides of parallelogram. This is the reason why we are saying that BC is equal to AP and BC is equal to AQ. So, if you talk about QR, QR is nothing but, see, QR is nothing but QA or AQ plus AR. AQ plus AR. AQ plus AR. So, what is AQ, children? AQ is nothing but BC plus, this is AR, children, sorry. BC is equal to AR. So, AQ is equal to BC, AR is also BC. That means what? 2 times of BC. Therefore, QR is equal to 2 times of BC. QR is equal to 2 times of BC. Similarly, we can prove we can prove that PR is equal to 2 times of AC. PR is equal to 2 times of AC and PQ is equal to 2 times of AB. Now, perimeter of triangle PQR is nothing but PQ plus QR, PQ, QR plus RP. This is equal to PQ. PQ, how much you have got? 2 times of AB plus QR. QR is 2 times of BC plus 2 times of AC. This is nothing but 2 times of AB plus BC plus CA or AC. AB plus BC plus CA or AC. So, AB plus BC plus AC is nothing but 2 times of perimeter of triangle ABC. 2 times perimeter of triangle ABC. For that, this is nothing but perimeter of triangle PQR is equal to PQ plus QR plus RP is nothing but perimeter of triangle PQR, that is equal to 2 times perimeter of triangle ABC. This is what we need to prove, and we have proved. Once again, children, there is a triangle ABC, and through A, QR is drawn parallel to BC, and PR is drawn parallel to AC, PQ is drawn parallel to AP. Now we need to prove that perimeter of triangle PQR is nothing but 2 times of perimeter of triangle ABC. So now ABCQ and ACBR, these are parallelograms because opposite sides are parallel. This is parallel to this, and this line is parallel to this line is parallel to this. So these two are parallelograms actually. When they are parallelograms, BC is equal to AQ, opposite sides of parallelogram. Also BC is equal to AR. So what we can say? BC is equal to AQ, BC is equal to AR. So what is QR? QR is nothing but AR plus AQ or AQ plus AR. AQ is nothing but BC, and AR is also nothing but BC, that is 2BC. QR means twice BC. Similarly, PR means twice AC. PQ is twice AB. So 2 times of AB plus BC plus CA. This is the 2 times of perimeter of triangle ABC. Perimeter of triangle PQR is equal to perimeter of triangle ABC. Please note it down, children. With this, I am going to conclude my topic today. In the next class, I will be doing the next part.